A table moves in a horizontal plane with simple harmonic motion. The table completes n oscillations per minute. Find in terms of mu and n the greatest allowable amplitude of the motion if an object placed on the table is not to slip, where mu is the coefficient of friction. So this table oscillates left and right about an equilibrium position. The equilibrium position could be here. So we could say this is 0 on the ground. So this point is underneath the center of the table. It does n oscillations in 1 minute. So it goes back and forth through its equilibrium position n times per minute. Now, we normally want to get the number of oscillations per second. So to do that, we have to divide by 60. So this means that we have n over 60 oscillations per second. So the frequency f of this simple harmonic motion is n over 60. In previous videos, we saw that the displacement of an object undergoing simple harmonic motion can be represented by a sinusoidal function or a cosinusoidal function, where a is the maximum displacement or the amplitude of the motion. Omega is known as the angular velocity. Omega is related to the frequency of the motion by the formula omega equals 2 pi f. So plugging n over 60 in for f, we get omega equals 2 pi times n over 60, which is pi times n over 30. We saw in previous videos that we can get the acceleration of an object undergoing simple harmonic motion by differentiating this function twice. If we differentiate it once, we get the velocity, which can be denoted by x dot. Differentiating this here, we get minus a omega sine omega t. That's just the chain rule. This was covered in a previous video. Differentiating cos gives us sine. Differentiating the angle gives us omega. And if we differentiate again, this is x, 2 dots, we get the acceleration. So this here is the velocity. So the acceleration is got by differentiating this. And when we differentiate the sine function, we get cos. By the chain rule, we differentiate omega t to give us omega. We multiply omega by minus a omega, so we get minus a omega squared. Now, the maximum value that the acceleration can have is this quantity here. So you could just memorize this formula, and we can ignore the minus sign. So the acceleration can be positive or negative. If we're just interested in the magnitude of the acceleration, we just take the magnitude of this quantity, which is a omega squared. So we have the magnitude of the maximum acceleration of the table. So this is a positive quantity. A is usually taken to be a positive quantity. It's the maximum displacement of the table, and hence the object, if the object is remaining with the table from the equilibrium position. Omega squared is of course positive. Now we can apply Newton's second law to get the magnitude of the maximum force acting on this object. We just multiply the mass by the acceleration. This is just F equals ma. That's what we're using here. So we just multiply m by a omega squared. Now the question is, what is the maximum force acting on this object? The object is remaining in contact with the table. So why is that? What is the origin of the force on this object? Well, it can only be due to the table. The table is pushing the object left and right, causing the object to oscillate about an equilibrium position with simple harmonic motion. That's the force of friction, essentially. The force of friction is constantly changing direction. When the table is moving to the right, the force of friction on the object is to the right. It's pushing the object to the right. When the table is moving to the left, the force of friction is pushing the object to the left. So it's just the fact that the table isn't smooth, so the object interlocks with the surface of the table to some extent. So when the table moves, it pushes the object. Now we're interested in the maximum force that can be exerted on this object. We know from previous videos that the friction force depends on the normal reaction or normal force on this object due to it being in contact with the table. That normal force is perpendicular to the surface of the table. Now, since the object does not accelerate in this direction, we have another vertical force acting on the object, that is its weight. That's its mass m times g. So since we're dealing with a horizontal surface, these forces must cancel out, so N must equal mg. The friction force depends on N actually. So essentially it depends on the weight, because in this situation for a horizontal surface, N is equal to the weight of the object. Now, say when the table is moving in this direction, the friction force will be acting on the object to push it to the left. So the friction force will be in this direction. The friction force varies from a minimum value of 0 to a maximum value of mu times n, where mu is the coefficient of friction between the surfaces. So mu depends on the material that the surfaces are made out of. So this is the maximum friction force. It should make sense that when the table is moving fast enough, then the maximum friction force will be applying, and if the table moves any faster, then this object will actually slip. If you think about it, the table can only push so much on this object. If it pushes any harder, the table will just slide under the object, if you like, so the object will slip. So we're assuming that maximum friction force is acting, so the table is moving fast enough but not too fast. We're interested in the maximum force acting on the object, so we set ma omega squared equal to mu times n. But n is of course mg. Also, I accidentally erased omega. We saw this earlier. So we can plug pi n over 30 in for omega, and we can solve for the amplitude. The amplitude will be given in terms of mu and n. M's cancel from both sides here. We plug pi n over 30 in for omega. We have to square it. So if we square it, we get pi squared n squared over 30 squared, which is 900. So then we have mu g divided by pi squared n squared over 900, or mu g multiplied by 900 over pi squared n squared. We can get A in terms of just mu and n by plugging 9.81 in for g and multiply 900 by 9.81, divide by pi squared to get 894.56.